Tell me. Alright, good afternoon. Good afternoon.
Good afternoon.
Very good, thank you. Alright, let's go through now a TPM activity. What is TPM? Is total productive maintenance. This is pioneered by Nippon Denso, is another group of company, is a part of Toyota group, and that is what TPM activity is all about. There are 5 pillars of this. One is equipment improvement, second is autonomous maintenance, third plant maintenance, quality maintenance, and early equipment management. Equipment improvement, we know that what are the improvements which we need to do in the equipment. That talks about the equipment improvement. Autonomous maintenance means the activity which we are supposed to do, the maintenance activity which have to be carried out on the machine on a daily, weekly or monthly basis, so that machine can run autonomously without any problem. That is what is autonomous maintenance. Third is plant maintenance. For example, there is a big plant, steel plant is there. You know, every 2 years they stop the machine, and the overall, that is called as the plant maintenance. Fourth is the quality maintenance. What is quality maintenance? In quality maintenance, if you want to improve the quality of the product, what maintenance activities we should carry out, that is called as quality maintenance. And fifth is early equipment management. Means what? For example, if you are procuring equipment from the machine manufacturer, if you go to them and tell them that these are the things which we need improvement in the equipment itself so that we don't face the problem in future, that is what is called as the early equipment management. But this is more theory kind of. We will focus only on autonomous maintenance, because autonomous maintenance is the key for the success of the manufacturing plant. So let's focus on that. What is autonomous maintenance? It's a 7-step autonomous maintenance in TPM or WCM. WCM is world-class manufacturing. So what is the basis of this? See, the most important thing is that is a team-based approach. To understand the team-based program involving operators of the equipment as well as the maintenance team, that is what is involved. And the key success of this autonomous maintenance is based on the very important concept of to change the attitude of acceptance. Now, what is the attitude of acceptance? If it is running, it's okay. That's where the problem is. As long as the machine is running, you continue running it. When it breaks down, we will see. For example, if there is a car, we don't have that attitude that if it is running, let it run, and when it stops, then you will do the maintenance. You don't do that, isn't it? For car, you send it for every 3 months, you send it for maintenance, for replacing oil and this and that. As a result of which, it doesn't start. But that doesn't happen with the equipment, and that's where the problem is. So what we are going to change is the attitude of acceptance. That's the key. So if it runs, it's okay. That attitude we have to remove from here. That is what is important. So what is the old attitude? I operate, you fix. Means what? If I am operating the machine, you fix the machine, that's it. My job is to run the machine, maintenance will come, and his job is to fix the machine. That is what the old attitude. I fix, you design. Means, for example, drawing and design department is there. Their focus was that maintenance department will do their job, design department will do their job. They will not talk to each other. Independent. You know, that is where the problem was. Then I design, you operate. Operator will do operations, routine work. Design department will do their design work. But in TPM, the attitude is that we all are responsible for the equipment. It's a complete teamwork. Okay? But this is an amazing principle called as zero breakdown principle, and all of you should know about it. It's an extremely important principle. What is that? It's a tip of the iceberg. You know what is the tip of the have you heard of iceberg? Yeah? What is the speciality of the iceberg? See, iceberg is like a mountain which floats on the sea, whereas this says that 1/10 of the portion is out, 9/10 is below the surface of the water, isn't it? And that's how the ships wreck, you know about Titanic and all. Same principle is here. When there is a breakdown, it's the tip of the iceberg. breakdown happens, it means that so many problems which are there which have not been addressed, as a result of which there is a breakdown. What are the, so what our principle is that expose the hidden defects and prevent the breakdowns before they happen. Means what? If a machine is there, if there is a wear, play, slackness, leakage, dust, dirt, adherence of raw material, corrosion, deformation, surface damage, cracking, overheating, vibration, noise, all these abnormalities are there. When these abnormalities, nobody notices that, a day will come when the machine will be break down. And then we say, oh my God, the machine has broken down. It has not broken down. We have ignored all of these. As a result of it, this machine has broken down. So what do? Expose all of these defects. So whenever there is a wear and tear, it should be exposed, means we should come to know before it should be addressed. If there is a play, suppose, there is a motor, there are two motors which are connected and the pulleys are connected. When there is a play in the motor and the belts are vibrating, it means that there is a problem. Correct there. If you don't correct that, what will happen? Bearing will get worn out. When the bearing gets worn out, it will get stuck. There will be load on the motor. Motor will get burnt out. And when motor gets burnt, we say, there is a problem with that. It didn't. There was no problem. You didn't either grease it or you didn't take action when there was a play. So idea is that expose all of these problems. Let it be, that is the fundamental principle. So anything you can see, you will correct it. If you don't see that, suppose there is now inside there is a machine here. Okay, there are gearbox and everything is inside there. If you can't see that, until the machine breakdowns, you will not open that. But suppose if it happens that this portion is transparent, and you make this transparent, as a result of which, what is happening inside, if there is a play, there is a leakage, you will be able to know. So make the machine transparent. As much, don't try to hide the problem. Expose the problem. Let everyone know what the problems are. And what we do when there is a problem, we try to put the tags, red tags and the green tag. We put as many tags as possible. Let it look like a Christmas tree, having so many tags there, 20 tags, 50 tags, it's okay. Once you are putting those tags, it means what? You are accepting that there is a problem. And the biggest thing is that once you accept there is a problem, you will be able to take action. Isn't it? When you try to hide, you don't expose, what will happen? Machine will get problems, and that is the time you will be stopping. Okay? Okay, there are reasons for losses. There are initially what happens, the sporadic losses are there. Then you neglect, then you will have chronic losses. Then there is slight abnormalities. You get further deterioration, then you get the poorly maintained machine. There is something called as there are 6 equipment failures. One is that, first thing you have to understand that in any machine, there will be breakdown failure. Second is the setup and adjustment. It's again loss. Because when you are setting up the machine is not producing, isn't it? So it's a loss. When there is a minor stoppage, sometimes it stops for 5 minutes, again restarts, that is the loss of this thing. Reduce speed. The machine's capacity is to run at 100 kg per hour, 1000 kg per hour, and you run at 700. Why? No, there is a problem, let me run it slowly. Reduce speed is a loss. Then quality defects and rework, and startup and reduce yield. So these are the different defects of it. We will not go into the details of this. We'll basically these are used to calculate the OEE, overall equipment effectiveness. How to calculate that is a separate issue. We'll tackle it afterwards. But we will focus currently only on few things of autonomous maintenance. That is, what is this autonomous maintenance activity? And what are we supposed to do during that meeting? Alright? So the 7 steps of autonomous maintenance, out of that, even if you do 3, 1, 2, 3, it's good enough. What are those? Conduct initial cleaning and inspection. Make the factory absolutely spick and span. No dirt, no dust. And any problem is there, expose that. Second is eliminate sources of contamination and inaccessible areas. Means what? Source of contamination. If there is a leakage from the oil, stop that. If leakage of dust is there through some area, stop it. That is the source of contamination. Dust source of contamination, oil source of contamination, stop that. Then inaccessible areas means what? When if you are not able to go inside if you have to bend and remove that part and it's very difficult, nobody will do it. So those inaccessible things you must stop them. They must be accessible basically. And third is establish provisional cleaning, inspection and lubrication standard. If you do these 3 steps, you are done. Your OE, your effectiveness can easily be achieved up to 85%, and that is what we are going to look at. So what we want to focus on, how to clean, how to inspect, how to lubricate, and how to come up with those standards so that it becomes way of life. Okay? So these are what are the things, goals of autonomous maintenance? Stabilize the equipment conditions and stop accelerated deterioration. You don't want the machine to further deteriorate. Okay, we want to stop it there. Control or prevent deterioration, make inspection and maintenance easier, increase the skill levels of the operators, and prevent deterioration related failures. So these are the cleaning and inspection. This is very important. When you clean, you develop a new eyesight of seeing what is invisible. Every operator, every supervisor must do the cleaning with your own hands so that he is looking for abnormalities. What are the problems and issues? Look for abnormalities and put tags. Okay. What we say, when you look for the nut bolt, it appears okay, but you actually find that they are playing. When you go there, you will find that the motor is overheating. So when you do cleaning, these are the abnormalities you will see. Put tags there and show that yes, we have identified this as a problem and we are going to take action to prevent that from further deterioration. So what do we do? In electrically stopped condition, when machine is stopped, these are the faults which we'll be looking for. What are the faults? Very dirty areas, unlubricated areas, loose fasteners, playing, out of alignment, straightness, wear and tear. All of these problems you have to look for when machine is in stopped condition. Okay? When machine is in running condition, these are the problems which you will be looking for. And when you find a problem, you have to make sure that you stop the machine, put tags there, and then take the corrective action when you are going for a weekly maintenance or other maintenance. So I think the machine autonomous maintenance will be formed with a team of people or 3 or 4 people. Identify, make their team, and every week they should meet to come up with the cleaning and the maintenance standard. That is what is looked at, and every hour they have to meet for 2 hours. These are the schedules which are to be done, and they have to attain that. Now let's focus on what are the things, what is tagging and untagging. Any problem is there on the machine, you have to either put a red tag or a green tag, and put as many tags as possible. Means what? It means that you have developed the eyesight for looking for the problems in the machine. And that is what is important. Once you accept that there is a problem, you will take corrective action. But if you don't accept the problem, then naturally you will have issues related with the maintenance and breakdowns. So this is the way to do it. Make a copy of each of the tags which is there, and you maintain a register, and what are the actions which you are going to take on that. Now generate 1 point lesson. Means every problem is an opportunity to learn. How are you going to do that? Create a 1 point lesson. What is 1 point lesson? Right way of doing it and wrong way of doing it. Display it at the Gemba. That is what is called as a 1 point lesson. For example, if you see, let me show it to you. Yeah. You put a wrong way of doing it and right way of doing it, correct way of doing it and wrong. Put a photos of that and display it there at the Gemba. For example, vibrating belt indicates that the belt is loose, because we know this vibrating belt eventually will burn the motor. So you show that this is the 1 point lesson created by the team of people, and show that it can cause your machine to burn. So right way of doing it, wrong way of doing it, these are the ways how you have to display it at the Gemba. Then you have to do the audit. For every equipment, there is a main body cleaning and tightening, there is an audit, whether, and then you mark from 1 to 5. If the condition is excellent, 5 marks. If the condition is very bad, then 1 mark. And check all of these activities and then do the audit. If it is above 80%, then you are doing good. If it is less, then you have to improve upon that. And that is what is the autonomous maintenance is all about. I think activities board, and see, you need to display as many things as possible. That is what it talks about. Try to put the sketches, right way of doing it, wrong way of doing it, your Viva analysis, display it there. What are the frequently recurring problems? Display. What are the areas where you should lubricate? What are the areas where you should have a cleaning schedule? All these things to be displayed. Your Gemba, your machine, your equipment should be full of instructions, full of displays, and that's how automatically you are training the people. And that is how you can reduce your breakdowns. Now if you see, the gauges are there. The gauge, the working zone marked as a green zone. How do you do it? Either you paint it or you put a green insulation tape there. So that when you are seeing it, if the indicator is there between green zone, you are okay. If it is not, you can immediately see that there is a problem. So make the Gemba visual. Everything should be made visual so that you can identify the abnormalities in the equipment. Write down what is the oil tank level, display that, gauges, motor, display the specifications of the motors, display the specifications of the gearboxes. Try to make the Gemba visual. That's what the whole idea is. Now if you see that initially this complete gearbox was completely hidden. Nobody could see that. When they took a project, they have made it with the transparent thing so that you can make out now when there is a problem. This modification has solved the plant reduced the breakdown of that plant by 30%. Because they could identify the problem. When there is a small problem, they will stop the machine, rectify and run it. Otherwise, whole breakdown will be there with the gears, whole gearbox is to be changed, it has to be bought, all those problems were there. So, when you make the Gemba and the machine visible, and you can see, you will be able to identify the problems at the initial stages. Okay, so these are the different countermeasures and steps. How do we increase your efficiency? It is called as overall equipment effectiveness. 5I analysis is a very good tool. Go to the root cause of the problem and take corrective action immediately. We have come up with OFI form, which we'll talk about it in the next session. That is also a very important step to improve the productivity. Okay, so in short, this is all about autonomous maintenance. Focus on finding out the problem, exposing them, recording them, and monitoring that. That is what all about autonomous maintenance. Thank you. Now, can I say, sorry. Now we'll talk about Kanban. Kanban inventory management system. This is again an inventory management tool. In Japanese, kan means card and ban means signal. So basically you are giving signal by using a card. Now you will be amazed, this system has been working in Toyota for more than 50 years now, even more than that. Because in 70 years. In 1960s and 70s, when there were no computers, this system was working, and you will be surprised to know that if there is a conveyor belt on which the first car is, say, Toyota Land Cruiser, second car will be some completely different model, third car will be completely third model, and they are assembling on the same belt. And for every car you need around 30,000 spares, 30 to 35,000. On the assembly line they assemble more than 1,000 spares. So the 1,000 spares for this car which are needed are completely different than the car which is next to it. and this was not coming, they were not assembling, and the spares were not coming just like that. It was not computerized. So they were using this Kanban inventory management system. So you can imagine how powerful this system is. And it's very easy to implement. Okay. So it's an amazing tool. You can learn from it, and it's a simple way of controlling your inventory. First thing, remember, inventory is a muda, is a wasteful activity. It's not adding any value. There is no change in physical or chemical property. So you need to avoid that. That's very clear. So in our journey towards zero inventory, what do we need to do? We need to reduce that. So how do we reduce it? What to keep should be identified. How much to keep should be identified. Where to keep, next to point of use. Like we say, pen we keep it here. Isn't it? Degree certificate not. So if the machine is maintained, whatever tools are needed frequently, you identify, make a place for that so that you can use them frequently. Then how to keep? That is the stores management. There are two types of inventory management system. One is called as VQFT, other is called as a FQBT. What is that? VQFT is variable quantity fixed times. Means what? Quantity is variable, but time is fixed to replenish that. Okay. Other one is fixed quantity variable time. Means quantity is fixed, but the time is variable. We don't know when we are going to replace that. I'll give you the examples of this so that you can understand. Suppose you decide that every Monday I'll fill the fuel in the car. How much fuel you will keep? Fuel, you don't know. Whatever has been consumed, you will make the petrol tank full. That's it. One week it can be 70 liters, other week 50, other third week for 30. But every Monday, what is that? Fixed time, variable quantity. So on every Monday, whatever is to make the tank full, you will fill it. That is called as the fixed time, variable quantity. Other is variable quantity fixed. Other is fixed quantity, variable time. Means what? Whenever, suppose there are 5 items are like this, 1, 2, 3, 4, 5, you keep them. Whenever it reaches 1, you will place order for 4. That is, quantity is fixed. I am going to place order for 4 all the time. But when, we don't know. Whenever it reaches 4, you will place order. If you do that, the difficulty about this is that today if this order gets finished, you will have to place order. Next day another spares get finished, you will have to place order. You keep placing order. So that is the reason we implement a simple system where it's called as a fixed time variable quantity. Means what? Every first of the month, you take the stock. Whatever has been consumed, you replenish. That becomes a very simple system which we use in our factories for the spares management. Now, variable quantity, fixed time, what happens? The pitch means time during the 2 successive replenishment. Means, say for example, in case of car, you are filling it every 7 days, isn't it? Every Monday. That is the pitch time. In our case, we, to my mind, every month we will take the stock and place the order. That is fixed time of 30 days. That is pitch time. Pitch time of 30 days. What is the maximum stock? See, why maximum stock is needed? Because you need to identify how much space will be needed. Suppose I am going to order this 5 every month, the requirement is 5, and your consumption during pitch time in 30 days is 5. You will go for another, say, 3 as a safety stock. So 5 plus 3, 8. You will make a place for keeping 8 items. That's it. And you will write down the name there. This sketch pen, whatever is there, 8 items, that is the maximum stock. So you don't need more than this. That is what is called as a VQFT system. And that is what we are going to use it in at our Gemba for the spares management. In case of fixed quantity variable time, it is a reorder level. When it reaches the reorder level, you are going to replenish that. That is called as the FQBT system. And here maximum stock is equal to reorder level plus standard delivery quantity. That is what it talks about, the FQBT part of it. So this is a very simple system. Where to keep, we have already talked about it. Now, how should we do the stores management? It should be search free. You should not spend time in looking for that. Where is it? No. It should be count free. What do you mean by count free? Like for example, Ramzan, in case of sacks which are there for firewood sacks, we say that we are going to keep it in such a way that you should be able to count. We know on an average is 20 kg is the weight of one sack. If there are 50 sacks, means 20 into 50 means 1 ton is the stock. Isn't it? That is called as a count free. So when you are stocking those items, you will put it in a block-like structure where the standard items will be there, so that you can immediately count 1, 2, 3, 4 layers are there, 4 bins are there, means we have got 4 tons of firewood, we have got 4 tons of material. So that is what the count free system. Air free means what? If this is one shelf, another shelf is here, and you keep this item here, what are you storing? You are not storing this item, you are storing air, isn't it? Have you understood? Now, for example, if this is a block where you are keeping this item, you are not storing this briquette here, you are storing air. So, what we do is that we make the shelf as per the requirement. Okay, and that is what is called as the air-free system. Bend-free means you should not get a lot of trouble in lifting that. The item which is very difficult and you have to bend, you will find that you will not go there, you will not prefer there to go. As a result of which, you will overlook that and you will have a problem. Climb free, you don't have to climb again and then pick up that. It's very difficult to access. Don't do that. Dust free means it should be clean, and FIFO and LIFO, first in, first out, and last in, first out. So these are the various stores management systems which are there. In engineering stores, what do you store? You store long lead items, spares for bottleneck equipment, and fast moving items. What are the long lead items? Lead items means which you are importing from, say, India or Europe. It takes long, it takes 3 months. So those are the items you must keep it in stock. Other spares for bottleneck equipment. Suppose you have got a generator in your factory. It's a bottleneck equipment, isn't it? If power goes, generator will start. If that spares is not there, whole factory will be in dark. That's the bottleneck equipment. Boilers are generally considered as a bottleneck equipment because if the steam is not there, whole factory will stop. Then the fast moving items, the items which are very low value, you need to keep them in stock. So what are the items which you are going to keep it in engineering stores? Only these 3 types. We don't want to unnecessarily increase the quantity. So how do we calculate that? Get 6 months consumption data based on the facts, arrive at the reorder level, and come up with what is the fixed quantity which you need to keep, etc. the way we talked about. Now this is the picture of the engineering stores. Can you see that it has been made as per your requirement? Whatever items are needed, the shelves have been made as per the requirement. Isn't it? It's the air-free system. So if you see it, you will find that it's a very simple to do, easy to manage, less space. That is how we use. And that is what the Kanban inventory management system is all about. So whether it's the engineering stores or raw material stores, what we need to do, make it search free, count free. It should be labeled what are the things which are there, and you should be in position to identify what type of raw material is there, and it should be displayed somewhere. That is what in essence we are looking at. Okay, this is very quick overview of Kanban inventory management system for our factories. Thank you.